embryo because we take out only a few cells from a very large embryo, where in the old days they used to take out one cell from an 8-cell stage embryo or a 6-cell stage embryo even, and so you're taking away a large amount of the mass of the embryo. Here we're just taking a very small number of cells from a very large, much larger embryo, so the impact is much more minimal. Now, does it have any impact at all? It's unclear yet. Nobody's been able to really detect that. I suspect whenever you do anything to any biological system, you perturb it somewhat.
Yes.
You can't get away without any damage, but the question is whether it's clinically relevant, or not, and whether the risk outweighs the benefits from it.
Right?
Yeah.
And how many of those have you done so far?
Pre-implantation genetics screening
Mm-hmm.
in the last, what time period?
Well, historically. So you
Well, we say in the last month.
10, 1, so
Yeah, in the last 3 months, about 100.
And historically, from the history that the ones that you have done, have you seen any issues after the birth? Or?
No, not yet. In other words, I guess the question is, you're asking is, does this cause birth defects in
Yes.
the baby?
Yeah,
And
well,
the answer is none have ever been described from the process of pre-implantation genetic screening. The only time that you potentially could have one is if the pre-implantation genetic screening misses one. So for instance, if it doesn't catch a Down syndrome, or if there's something else that, that's present that it won't see.
Is it a 5-cell blastocyte that you're taking it out of?
We're taking it out of a 124-cell blastocyst, and we take out about 3 to 5 cells from 125 cell or more, 128 cell or more. Sometimes they can be a little bit more, sometimes a little less. The smallest ones that we probably biopsy are closer to about 64 cells. So it's still a very small portion. Plus, we don't take it out of the baby part, we take it out of the placenta part. So there's two components. When we actually do a biopsy, you can do it, what we do is a trophectoderm biopsy. The trophectoderm is destined to become the baby's placenta, not the baby. The baby part is in the inner cell mass, so that's like an island in the middle of this big ball of fluid, and we don't touch that.
Okay.
So it's only the placenta part that we touch.
Okay.
And that's probably why we don't see any
Okay.
developmental abnormalities, because you're not taking anything out of the baby.
Okay. And that's allowed by FDA, so that there are
Yes.
no issues.
No issues. Probably the amount of patients that are getting PGS, now that the system's been refined and we're doing biopsies from the blastocyst, is now skyrocketing. So it may become the standard of care, I think, before too long, where biopsy is going to be mandated for every embryo before they're put back in, to really screen out a lot of these abnormalities. And many patients are demanding that now. They really want to know before they put an embryo back in, does it have Down syndrome, does it have trisomy 18 or trisomy 13, one of the ones that can make it a far distance in the pregnancy, or are these destined to become a miscarriage? Because no one wants to do a futile transfer where you put back in an embryo and it doesn't implant.
Yeah.
So that's another reason why people are doing this.
Okay, good. And in your first speech, you mentioned a test that it can be done at 10 weeks?
Yes,
With,
yes.
blood sample.
Absolutely. So, let's say you don't want to do the pre-implantation genetic screening, but you're still concerned. Now remember that in light of the fact that donor eggs are used, and donors are typically between the ages of 21 and 29, the absolute risk of having a chromosomal abnormality in the embryo is very, very low. In fact, the risk after 9 weeks of pregnancy is less than 1 in 1,000. So now, if you still want to have genetic screening done, you could do a non-invasive test. Before this non-invasive tests were available at 10 weeks of pregnancy, we used to have to do something called an amniocentesis, which is done usually around 16 weeks of pregnancy, when the pregnancy is more developed and the baby develops in a fluid called an amniotic cavity. So a needle is placed through the abdomen into the amniotic cavity, fluid is extruded, and then that fluid has fetal cells in it. And then you can take those cells, grow them, and then analyze them, analyze the chromosomes. But now there are several companies, including a company called Sequenom, which is developed, and Natera, Sequenom, several companies. I think there's about 4 right now in the United States. And what they do is they take a blood test from the surrogate at 10 weeks of gestation, and that blood test will analyze free fetal DNA. And what it'll analyze it for is typically for the 2 main abnormalities that we're concerned about, and that's trisomy 21, which is Down syndrome, and trisomy 18. So those are the ones. Why are we concerned more with those? Is because those are associated with you can actually have a live birth with trisomy 18 and trisomy 21. The rest of the chromosomal abnormalities, like let's see if you have an abnormal chromosome 13 or 11 or 12, the overwhelming majority, almost 100% of those will miscarry before 9-10 weeks of gestation. So now you can get a blood test, and when I talk to my intended parents, I always talk about this blood test because I would want my sister or wife to have that done if she were to be pregnant. So that's done at 10 weeks. Now we have to order it beforehand, so you have to make sure that when the surrogate comes into the OB's office or into our office, is that we have a kit ready, we draw her blood, and within a week you get the results. So that's a great test because now we don't have to resort to the invasive amniocentesis test. Now amniocentesis is fairly low risk. The risk of a pregnancy loss is probably somewhere around 1 in 200 to 1 in 400. That's still a significant rate. With a non-invasive blood test, you can get away from that.
Okay. Great, thank you.
How much is that procedure? This new
Do we know how much the Natera takes? I have a feeling that you're talking about a few $100s.
Okay, and what week is it possible?
10 weeks of gestation. So the earliest you could do it, in fact, we were one of the centers that did these studies with Sequenom. What we did was we drew blood from pregnant patients at 6 weeks of gestation, at 8 weeks of gestation, at 10 weeks of gestation. And we did that over a year. And then what we found out was that 10 weeks was the most sensitive in terms of doing the analysis. So we actually worked with that company, Sequenom, but you can work with any company you wish. We just did the research trial with them.
So is the office adjusting was Las Vegas?
Yes, we have an office in Henderson, Nevada, which is just outside of Las Vegas, and then we also have an office in Summerlin, which is just sort of west of Las Vegas.
Yes, for your clients, do they need to come to your office?
Yes, so we have essentially surrogates and egg donors travel to us, because most of our surrogates and egg donors are from outside the state. They travel to us for a day. We make all the arrangements for their travel. We have a concierge service at our center, make all their travel arrangements. They come there for all their testing, so they spend several hours at our office for all their testing of psychological screening, infectious disease, genetic screening, and then what we do is we get all that information, and then the next time they come in is when we do their embryo transfer or their egg retrieval. And wherever the surrogate or the egg donor is, where their home is, that's where they get monitored essentially.
Okay.
I think I have to give, are we going to a different room?